Hello guys, Vikas this side. In today's session, we are going to discuss redox reactions, where we'll be covering all the points mentioned in our syllabus according to the Cambridge IGCSE curriculum, O levels or our regular GCSE exams. We'll be covering all the points. So if you face any issues in the topics like oxidation, reduction, redox reactions, what is oxidizing agent, what is reducing agent, how to identify these in a given reaction, and then what is oxidation number, how to identify oxidation number. If you face any issues in topics like these, all these topics will be explained to you clearly in this today's session. So let's start with the session. Now the topic's name is redox reaction. So first of all, we need to break this term. What does redox reaction means? Now, if you look at the term redox, the first word is RED, that is red. It stands for reduction. What is reduction? We will understand it. Have some patience. Ox means oxidation, so that is oxidation. Means we can say redox is a reaction in which both oxidation and reduction takes place. That's it. So this point should be clear to all of you. Now, the question arises, what is oxidation? What is reduction? Now, in order to make it very simple, the least we can say is that oxidation is something in which there is addition of oxygen taking place. So, I'll write addition of oxygen, or we can say oxygen gain. This is a very basic point which all of us can understand very easily. What is oxidation? Oxidation is gain of oxygen. Now, in order to understand it more conceptually, we need to understand what is the role of oxygen. Now, as all of you must have seen that whenever oxygen combines with some compound, let's say calcium oxide is here, then you have aluminum oxide is there. All of you must have already seen that calcium always has a charge of positive 2, oxygen always has a charge of negative 2. You must have seen this somewhere, at least your teacher might have written it on the board sometimes when explaining the concepts to you, or you must have seen this in your textbook or somewhere. You must have seen that known metals tend to develop negative charge around them, because that is the only way they can gain stability. How you can assume this is that non-metals are always electron deficient, so they always want to gain some electrons. This also proves the point that oxygen also makes a charge of negative 2. Whenever oxygen is present in a compound combined with some other element, oxygen is always in the form of negative 2. What does negative 2 charge means? Negative 2 means in order to be stable, it has gained 2 electrons. This is the point. So in order to be stable, oxygen has gained 2 electrons. Now, we can come down to a common point that whenever you add oxygen to something, now just think about it conceptually. So if I'm adding oxygen to calcium, we all know that we will get calcium oxide. Fine. Then we can balance this equation. I'm not balancing it, just understand the concept. So when we are adding oxygen to calcium, what does calcium do? Calcium loses electrons, it's a metal. And what does oxygen do? Oxygen gains those electrons. So now, don't you think it means that whenever you are adding oxygen to something, there is going to be loss of electrons in that species? Just like this case, you are adding oxygen to calcium. So what is happening to calcium? Calcium is losing electrons if you are adding oxygen to calcium. I hope this makes sense to all of you. So oxygen is also loss of electrons. So oxygen is also loss of electrons, and it is also gain of oxygen. I hope this makes sense to all of you now. So oxidation, we have discussed these 2 points. Oxidation number, what is oxidation number? This we'll be discussing a bit later. Now, reduction is the opposite of oxidation. This is what all of you can remember. So if there is loss of oxygen, sorry, loss of electrons is oxidation, then gain of electrons is reduction. Now, all of you can also remember this mnemonic, oil rig. It says that oxidation is loss, rig stands for that reduction is gain of what? Of electrons. So conceptually we have understood this, that whenever you add oxygen to something, that particular species is going to lose electrons. So oxidation is loss of electrons. And it is also the basic obvious point, gain of oxygen. Now if you do the opposite of this, that will be the opposite of oxidation, which is reduction. So reduction will be gain of electrons and loss of oxygen. Alright, this should be clear to all of you. Now moving on, then there is this term oxidation number. I've also pasted some kind of a meme here, that oxidation number, what is this? A lot of students have confusion that what is oxidation number, what is valency, what is the difference between oxidation number and valency. This we will also discuss. For now, let's first focus upon what is oxidation number. See, in layman terms, if I had to tell you, I can tell you that oxidation number is the charge. For example, we discussed O2 minus here. So what is the charge on oxygen here? -2. So the oxidation number is -2. So what I have written here, oxidation state is the charge on an atom when it is in combined form. That is the point you should pay attention to. Whenever an element is present in combined form, so the charge there on it is the oxidation number. One example, just like we discussed calcium oxide. So we are well aware that calcium being a group 2 metal, it has a charge of +2. Oxygen being in group 6, or you can call it group 16, it has a charge of -2. So what is the oxidation state of calcium? It is +2 here. What is the oxidation state of oxygen? -2. But this is under what condition? When it is combined with other atoms. Here calcium is combined with oxygen. So oxidation state is simply the charge on an atom when it is combined with other atoms, because there is a chance that one atom might be losing electrons, the other one might be gaining electrons, just like ionic bonding. What is ionic bonding? Metals combine with non-metals, metals lose electrons, non-metals gain electrons. That is ionic bonding. So the charge on atom is the oxidation number or the oxidation state. It is the same thing. Now after this, there is this confusion that, so is valency equal to oxidation state? In a way it is, in a way it is not. I'll clarify what do I mean by this. I've written, so valency is equals to oxidation state, question mark. Answer is no. Why? Have a look at this carefully. What is valency? Valency is the combining capacity of an atom. Then what is oxidation state? Oxidation state is when it is already combined. Notice this point. We discussed calcium oxide. So in this condition, calcium has already combined with oxygen. So charge on an atom when present in a compound is oxidation state. And for a lot of cases, oxidation state is equal to the charge or the valency. I'll give you a lot of examples after this theory is done. Do not worry, it will all be clear to you. Now, for now, what is the difference between valency and oxidation state? The main difference is valency is just a number, it is not negative or positive. This I have written positive and this is negative. So valency is never positive or negative. Valency doesn't have a charge, it's just a number 1, 2, 3, 4, 5, 6, 7, 8, whatever it is. Oxidation state is always with charge because it is only when the element is combined with some other atom. So when they are combining, there must be gain or loss of electrons. And if there is gain or loss of electrons, there needs to be positive or negative charge. It cannot be without charge. That is why it is either negative or positive. It is not just a random number. Now, moving on, let's understand with this some examples. See, if you see Na, you will check that Na is in group 1. Group 1 has valency of 1, right? So what is the valency of Na here? 1. Now, what is the oxidation state of Na? Oxidation state of Na will be in a compound and that will be positive 1. Why? Because Na always wants to lose 1 electron. So if it wants to lose, charge will be positive, and 1 because it wants to lose 1 electron. Let's look at another example, chlorine. So if you see chlorine in the periodic table, it's in group 17. Valency is 1. Fine, we are clear with that. And valency is without charge, so I've written 1 only. Fine. Now what about the oxidation state of chlorine? Oxidation state of chlorine will be negative 1. Now you see, you can clearly notice the difference. The number is exactly the same. There is a difference between the charge. Valency is without charge. Cl oxidation state is with charge. Why? Because chlorine being a non-metal, non-metals want to gain electrons in order to gain stability. So that is why chlorine has a charge of negative. Another example, hydrogen. What is the valency? 1. What is the oxidation state? Plus 1. Because hydrogen always prefers to lose 1 electron. Now, there might be this confusion that how do we differentiate what is the oxidation state, what is valency? We are noticing that in a lot of cases, oxidation state is numerically equal to the valency. So how do we figure this out? I'll give you a pro tip here. Remember this point that except transition elements, valency is always equal to oxidation state numerically. Numerically means only according to the number, not the charge. Charge you will have to decide. How you can decide? If it is a metal, charge will be positive because metals want to lose electrons. And when there is loss of electrons, positive charge builds up. And if it is a non-metal, it will be negative charge. For example, we discussed Na. We found out that Na belongs to group 1, so valency is 1. Now, how to figure out its oxidation state? It's a metal, charge will be positive, and it wants to lose 1 electron, so plus 1. Another example, oxygen is a non-metal, valency is 2 because it wants to gain 2 electrons. Now, oxidation state will be negative 2. Why negative? Because it wants to gain. Sorry. Now, fluorine. If I look at fluorine in the periodic table, I'll notice that it is present in group 17 top. It is at the highest position in group 17. Valency is 1. Now how to find out the oxidation state? What is the charge on it? Is it a metal or non-metal? Fluorine is a non-metal. Non-metals want to gain electrons or lose electrons? They want to gain electrons. And if there is gain of electrons, what kind of charge builds up? Negative charge builds up. So the oxidation state will be negative 1. Another example for all of you, sulfur. What is the valency? 2. Oxidation state will be negative 2 because it's a non-metal. Another example, aluminium, valency is 3. What will be the oxidation state or charge? Positive 3 because aluminium is a metal. Metals want to lose electrons, and if there is loss of electrons, positive charge builds up. Now this must be clear to all of you. Moving on. So now the question is that I understood how to find oxidation state for non-transition elements. I'm again repeating the pro tip. What all of you need to understand is that except transition metals, I'm saying except transition metals, all the all the elements in the periodic table have oxidation number similar to their valency numerically. And the examples we have done, if the valency of aluminum is 3, what is the oxidation state? Plus 3, because it's a metal, so plus charge is there. If the valency of magnesium is 2, so the oxidation state will be plus 2 because it's a metal, metals want to lose electrons. So according to our curriculum, IGCSE, O levels or GCSEs, this is more than enough that you need to know for the oxidation number. Sorry. Now, okay, I understood how to find oxidation state for non-transition elements. How do we find oxidation state for transition elements? This is a good question. We understood how to find for non-transition elements, but how do we find oxidation state for transition elements? Now the question is, why do we need? Because in the periodic table, all of you have studied this point as a feature of transition elements, that they have variable oxidation states. Alright. Now if you have this question, why do they have variable oxidation states? This we can discuss in some other chapter. Usually it is taught to you in IBDP or Cambridge ASA levels. So we're skipping this for now. So now, let's say we have copper oxide. We have to find oxidation state for copper. How do we go about this? See, there is a simple point that copper oxide is written here. What is the total charge on this compound? 0. So I can say that the sum of charge on copper and oxygen is equal to 0. Assume it to be like a box. There is a box, total charge is 0, there is x and y. So there is a possibility x could be positive, y could be negative, right? But the sum of these two should come out to be 0, just like in the case of copper oxide. So how can we solve this? So the charge on copper oxide is 0, and we are aware that oxygen's oxidation state is fixed, it is -2. Copper, I am not aware, so I am taking copper as x. So x plus -2 is equals to 0, because the sum of these two should be equal to 0. So what is the charge on copper? +2. Let's try some other examples. Cu2O3. I have to find the oxidation state of copper here. Fine. Now, this topic is very easy. Follow the steps. First step is you have to figure out what is the total charge on this compound. Compounds are always 0 charge, so this is 0. Fine. Now, just think about it. Does this mean the sum of oxidation state of copper with oxygen, the sum of these two must be 0, right? Alright. So if you agree on this point, this question will be easier to solve. How many copper atoms do we have here? We have 2 copper atoms. So I'm taking single copper atom as x. So I'm doing 2 times x. Plus, how many oxygen atoms we have here? We have 3 oxygen atoms here. And what is the charge on single oxygen? Charge on single oxygen is -2. And the sum of these should be equal to 0. So 2x minus 6 is equals to 0, 2x is equals to +6, as is x is equals to +6 by 2, which is +3. You can put it down in the calculator, you will get the same answer, +3. Alright. Now, moving on. I'll just erase this. Now there are some polyatomic ions which we need to be knowing according to our syllabus. One is sulfate ion, SO4 2 negative. The other one is carbonate, CO3 2 minus. Nitrate, NO3 minus 1, OH negative. That is hydroxide ion. Now let's say if you have to find oxidation state of copper and CuSO4. Now the remembering the polyatomic ions make it very easier for you. You know that SO4 has a charge of negative 2. So I'll write negative 2 here. What is the charge on copper? I'm not sure. That is what I'm trying to find out. So I'll take copper as x. So x plus negative 2 is equals to 0. What is the charge on copper? It is positive 2. So this is the charge on copper. Alright? Great. Now, some few rules that I've taken from our Cambridge syllabus guide only. It's clearly written there that you need to be knowing these points. Fine. We have discussed one out of these two. We have already discussed the most important one. The other ones are quite basic. Now, the first point we need to discuss is that oxidation number of an element in uncombined state is 0. And this should be obvious by now because when we discussed oxidation number, see, I have written oxidation state here. What is oxidation state? It is the charge when it is in combined form. But in elemental form, it is not combined. So if it is not combined in elemental form, there will be no charge. Charge is 0. So this is the point all of you need to remember, that oxidation state elements in their uncombined state is 0. Sorry. So the oxidation state in uncombined form is 0. Now this question arises that how do we know what is the elemental form? I am here. I'll help you with that. All of us need to know is that there are diatomic molecules, there are monoatomic molecules. So hydrogen, oxygen, chlorine, fluorine, bromine, iodine, nitrogen, these all are diatomic molecules. What does diatomic molecules means? That they exist in diatomic form in nature. Like if you see nitrogen, this is the elemental form of nitrogen. If you see oxygen as O2, this is the elemental form of oxygen. The air around us contains nitrogen and oxygen mainly. So nitrogen is present in the form of N2, not N. It is present in the form of N2. The oxygen which we consume on daily basis, every time, every single second, that is present in the form of O2. So the elemental form is O2. So the first point should be clear to all of you. Oxidation state in uncombined state is 0. Like, how do we know the elemental form or the uncombined state? I am telling all of you. These are the ones you need to remember. Hydrogen, oxygen, chlorine, bromine, these are diatomic. Then all the metals are monoatomic. So if you see something written like this, Fe only, it should be clear to you that this is a metal and this is present in elemental form. So the oxidation state will be 0. Then next point, I'll show you the C part first of all. See what they have written here. The sum of oxidation numbers in a compound is 0. We have already discussed this. These points, copper oxide. How did we solve this? We understood that total charge is 0. So the total oxidation state is 0. Means the sum of copper charge and the sum of oxygen charge should be equal to 0. So this we have already done. Sorry. The sum of oxidation number in an ion is equal to the charge on ion. This point we will discuss. Let's first of all go through the B point. B point is the quite obvious one. It's very simple. The oxidation number on a monoatomic ion is the same as charge. We have also discussed this point that If F negative is written, what is the oxidation state? -1. What is the charge? -1. So for monoatomic ions, charge is the same as oxidation state. I've written 4 examples here. You can see all of them. Copper 2 plus is there, oxidation state is +2. What is the charge? +2. Al3 plus is there, oxidation state is +3. What is the charge? +3. H plus is there, oxidation state is +1, charge is +1. That's it. Now the fourth point. Understand the 4 point carefully. The sum of oxidation numbers in an ion is equal to the charge on ion. Let's understand this with an example. Here we have this ion MnO4 with a total charge of -1. Now let's read the statement once again. Sum of oxidation numbers in an ion means the sum of oxidation number of manganese and the sum of oxidation number of oxygen is equal to the charge on ion. What is the charge on ion? -1. So I've written this here that sum of oxidation state of manganese and oxygen is equals to -1. Now let's say I tell you that manganese oxidation state is +1, +7. So how many manganese are there? 1. Charge will be +7. Oxygen, we are already aware, oxygen has a charge of -2. How many oxygen are here? 4. So 4 times -2 is -8 and +7, -8 plus 7 is -1. So this point is in fact true. That the sum of oxidation states in an ion is equal to the charge on the ion. Let's try another example. You have Cr2O7 negative here, and we are trying to find out oxidation state of chromium. Alright, how many chromium do we have? We have 2. Single chromium I will take as X, so I'll say 2 times X. How many oxygen do we have here? 7 oxygen. What is the charge on single oxygen? -2. And what is the total charge? You can just equate it and you will get the answer here. See, it's in front of you. Go through this carefully. This concept we can also use to find out the oxidation state on transition elements. Like in this case I am solving here in Cr2O7 negative. What is the total charge? Total charge is -2. Then you can take chromium as X. How many chromium do we have? 2. So I did 2 times X. How many oxygen do we have? 7 oxygen. So I've written 7 here. What is the charge on single oxygen? -2. So I've done 7 times -2. So what is X coming out to be? X is coming out to be positive 6. Alright, so this D statement is in fact quite similar to the statement C. Only difference is that in C, total charge is always 0 because we are talking about a compound. But in D, we are talking about an ion, so total charge is always equal to the charge on ion. The other processes, other steps are the same. What are we doing? We are ultimately summing up the individual oxidation states. We are adding the oxidation state of manganese with oxygen so that the charge of -1 must be there. But in a compound, it equates to 0. In a compound, the sum of oxidation states equates to 0. Another example I'll give all of you. Understand this carefully. Copper oxide and this same example which we did. What is the difference between these two? Here the total charge is 0. Here the total charge is -1. But does it make the process to be different? No. What you have to do is you have to again do the sum of oxidation state of copper with the oxidation state of oxygen will give you 0. So I'll take copper as X, oxygen as -2. That will be equal to 0. What will you do in case of this ion? In this case, the sum of oxidation state of manganese with oxygen must be equal to -1, not 0. In a compound, it is 0, which we have done here. But if they're talking about an ion, it must be equal to the charge on the ion, which is -1. That's it. The process is the same. What you will do, you will take manganese as X. How many oxygen are there? 4. What is the charge on single oxygen? -2. So X plus 4 minus 2 is equals to, what is the total charge? -1. That's it. Now, let's start with identifying redox reactions. Alright guys, now moving on, we are going to start identifying redox reactions. We have already discussed the basics of redox reactions. What is oxidation, what is reduction, how to find oxidation number, how to find oxidation number in transition elements, the compounds which are made up of transition elements. That we have already done. Now let's start applying those concepts in the equations. Alright. So a few basic rules that we must revisit. Oxidation states in uncombined form or the elemental form is 0. What are the elemental forms? All are written here. We have already discussed this. So let's see. If you look at Na here, it's in elemental form, so the charge is going to be 0. So the oxidation state is going to be 0. Fine. If you look at HCl here, it's a compound, so the total charge is 0, but individually one will have positive, the other one will have negative charge. Chlorine being a non-metal, non-metals want to gain electrons. So chlorine has a valency of 1, oxidation state will be -1. Hydrogen always forms +1 with non-metals. Now if you look at the product here, NaCl, what is the charge on Na? +1, chlorine -1, H2, hydrogen is an elemental form here. Elemental form, what is the charge? 0. So now you look at the charges that Na is going from, in reactants it has a charge of 0, but in products it has a charge of +1. How do I know it is +1? Beta, look at the periodic table, find out group 1. Group 1 are metals. Metals want to lose electrons. Group 1 has a valency of 1. And if they want to lose electrons, the oxidation state will be +1. So that is why Na is +1. So Na is going from 0 to +1. Fine. Is this gain of electrons or loss of electrons? This is loss of electrons. Earlier it had a charge of 0. Now it has a charge of +1. Means there is deficiency of electron. Positive represents deficiency of electrons. So this means there is loss of electrons. Now if you see at oxidation number has increased. It is going from 0 to +1, right? So there is increase of oxidation number, and we are saying there is loss of electrons. So this is oxidation. If you're going from 0 to +1, this is definitely increase in charge or oxidation number. And we also know that this is loss of electrons. Now let's revisit the first page of our document. See what I have written here? Increase in oxidation number is also oxidation, and here we have also written loss of electrons. Sorry. Now it must make sense. Na is going from 0 to +1. I'm saying this is loss of electrons, but this is also, yeah, Na is going from 0 to +1. So we are saying this is loss of electrons, but this is also increase in oxidation number, isn't it? Right? So that is why increase in oxidation number is also oxidation. Okay, so I have provided all of you with the reasoning here. Make sure to go through the notes. The reasoning is very simple. It will be very easily understandable. Now, if you look at hydrogen, see, hydrogen in HCl has a charge of +1. But in the products, it is present in elemental form. What is the charge on elemental form? What is the oxidation state in elemental form? In elemental form, oxidation state or charge is always 0. So, hydrogen is transitioning from plus 1 oxidation state to 0. Means earlier it had deficiency of electron, now it doesn't have any deficiency. If you're going from plus 1 means deficiency of 1 electron, to neutral. Neutral means no deficiency. So earlier you had deficiency of 1, now there is no deficiency. So this is gain of electrons. So gain of electrons, or we can also say decrease in oxidation number, because it is changing from plus 1 to 0. The number is decreasing, right? So this also supports our first point, that reduction is gain of electrons, true, but this is also decrease in oxidation number. Hydrogen is going from plus 1 to 0. So gain of electrons is there, right? But this is also decrease in oxidation number, isn't it? Think about it. All right? Okay. Now, another example for all of you. Understand this carefully. This is very easy. Now, if you look at copper here, copper is an elemental form, right? In elemental form, we have discussed one single point, that the charge is 0. So oxidation state is 0. So I've written the same thing here, elemental form, oxidation state 0. Let's look at oxygen. Oxygen is again O2, that is the elemental form of oxygen. So what is the oxidation state or charge? 0. Now let's look at the product. There is a single product which is copper oxide. We are well aware that copper oxide is a compound, means copper must be positive charged, oxygen must be negative charged. And we already know that oxygen always has a charge of -2 in a compound. Remember the point. Oxygen has a charge of -2 in a compound, not an elemental form. Elemental form it is 0, which I have written here. So do not confuse these 2 points. When in a compound, metals develop positive charge, non-metals develop negative charge. But in elemental form, the charge is 0. This is not rocket science. Understand this. So oxygen is -2, copper is +2. Now let's look at copper. Copper is going from 0 to +2. So there is loss of electrons and increase in oxidation number, hence oxidation. Oxygen is going from 0 to -2, means there is gain of electrons, decrease in oxidation number, which is reduction. Alright. So if you sorry, if you have this phase, you're not sure that how is copper +2. I've given you the explanation here as well. Copper oxide total charge is 0, means sum of oxidation state of copper and oxygen must be 0. Copper I am not aware, so copper I am taking as X. Oxygen we are very well aware. Oxygen is -2. Total should be 0, so X is +2. This is how we got copper as +2. Alright, now the last point remaining in our theory is oxidizing agent and reducing agent. Now I'll tell you the short trick here first. In order to get your all questions right, you can remember only these 2 simple points, that the species getting oxidized behaves as reducing agent. The species getting reduced behaves as oxidizing agent. If you remember these 2 points, all of your questions based on identifying the oxidizing agent, reducing agent will be correct. I am repeating myself again. If there is a species that you have identified which is undergoing oxidation, so if it is undergoing oxidation, means it is the reducing agent. And if there is a species which you have identified as undergoing reduction, so if it is undergoing reduction, that is an oxidizing agent. I've written the same statements here. Substance which oxidizes other substances but itself get reduced. What is reducing agent? Substance which reduces other substances but itself gets oxidized. Now, those who want to understand the concept and who are feeling a bit like this person, now I'll explain it conceptually in detail. But for your exam point of view, only you needed to know this. Now, let's understand in detail. See, so what am I saying here? I am saying what gets oxidized behaves as a reducing agent, and whatever gets reduced behaves as oxidizing agent, right? This is what I'm saying. Let's prove this here. All right, sample equation in front of us: magnesium combining with oxygen to form MgO. Now we are well aware that magnesium is in its elemental form, so the oxidation state will be 0. We are again very well aware that oxygen is a diatomic molecule. It's not monoatomic, it is diatomic. So O2 is written, so the elemental form it is present. In elemental form it is present here, so the charge is or the oxidation state is 0. Fine. Now MgO is in a compound, means magnesium being a metal must be positive 2, oxygen being a non-metal must be negative 2. Magnesium belongs to group 2, so the oxidation state should be plus 2. Oxygen belongs to group 16, the oxidation state is minus 2. Now, understand this thing here. Magnesium is going from 0 to plus 2. Fine. This is loss of electrons. Also, increase in oxidation number. Fine. So, this is oxidation. Oxygen is going from 0 to minus 2. This is gain of electrons. That is decrease in oxidation number. That is reduction. Fine. This we have already studied. Now, the twist of oxidizing agent and reducing agent, how to identify these? Pay attention carefully. Now understand this point. Magnesium is losing electrons. We have already written this here. What is new? Magnesium is losing electrons. Now just think about this. Where are these electrons going? One is losing, the other one is gaining, right? And gain is reduction, loss is oxidation. So magnesium is losing electrons, but where are these electrons going? These electrons are going to oxygen. Oxygen is gaining those electrons and it is getting reduced. Now just think about it. Sorry. Now just think about it. Magnesium is losing electrons. Oxygen is gaining those electrons. Gain of electrons is reduction. And which electrons are these? These electrons are from magnesium. So can't we say that magnesium is helping oxygen to get reduced? Think about it. Because oxygen is gaining the electrons from magnesium. Magnesium is getting oxidized, but it is helping oxygen to get reduced. Think about it. I'll repeat this again. Magnesium is losing electrons. Where are these electrons going? These electrons are going to oxygen. What is oxygen doing with these electrons? Oxygen is gaining electrons and is getting reduced. So that is why we can say magnesium is helping to reduce oxygen. This is why this point, that whatever gets oxidized behaves as a reducing agent. Magnesium got oxidized here, but it helped to reduce oxygen. It must be clear now, right? So there is this photo I have attached here as well, that if A is oxidized, then A must be behaving as reducing agent. If B is reduced, it must be behaving as oxidizing agent. Let's understand it through another example. Na plus HCl gives NaCl plus H2. Na elemental form charge 0. Hydrogen HCl in a compound, H will be positive, Cl will be negative. NaCl again a compound, Na will be positive 1, Cl will be negative 1. hydrogen elemental form charge will be 0. Sorry. So now Na is going from 0 to plus 1, means this is loss of electrons, increase in oxidation number. So Na is getting oxidized. Now again, you can just remember that whatever gets oxidized behaves as a reducing agent. But if you want to understand it more conceptually, just think about it. Na is losing electrons. Where are these electrons going? These electrons are going to hydrogen. Hydrogen is gaining those electrons. So Na is helping hydrogen to get reduced. So Na is getting oxidized, that is true, but it is also helping as a reducing agent. That's it, guys. We are done with the topic. Now, briefing you about the IGCSE pattern and the redox, how much weightage is there. If you have your 40 marks MCQs, the 40 question MCQ paper, roughly there is always one question which belongs to redox, and there they always ask you identify oxidation, identify reduction, identify oxidizing agent, identify reducing agent. In the theory paper, there is hardly one question you might find for redox. It's not that important according to the curriculum, but if you want to understand all the topics, charges, oxidation states, then it's a must topic. You need to be knowing about the charges. So redox is just like a chapter which builds your basics for the further chemistry. In MCQ papers, you'll always find one question for redox, and in the theory paper you might not find exact question belonging to redox, but there are some ionic equations which use the concept of redox. Those questions are always there. As you must have done in electrochemistry, a lot of ionic equations are there, so those are also based on the concept of redox only. Now I'm hoping this is you, a happy person. Your all concepts must be clear by now for redox reactions. Now, for your benefit, I have attached some MCQs from past paper questions here for redox. And these are the exactly type of questions which come for redox reactions in our syllabus. So all of you can give these questions a try. How many questions I've put here? Around 23 questions are there, and mark schemes are also there. All right. We can try some question. Let's try question 11. This is a past paper question. They are asking identify what is oxidation reaction. Oxidation means gain of electrons. Sorry, not gain of electrons. Gain of oxygen, loss of electrons. So is this gain of oxygen? Yes. I'm sorry, my health is not so good today. So carbon is gaining oxygen and it forms CO2. That is correct. So this is gain of oxygen. Calcium, CaCO3, CaO, CO2. No. No. So the answer should be A. Now, one tip, also remember this fact that in this case, there was a single carbon, then you added oxygen to this, it became CO2. So this is quite clear to me that this is oxidation reaction. But now, let's try this question. This question was also in a past paper question. I'm not sure which year it was. I'm not sure which year it was, but it was there. One of the options was this. Now, if most of the students, what they will do is, they will see that is the oxygen number increasing. यहाँ पर here we have 3 oxygens, here we have 4 oxygens. So oxygen number is increasing, means this is oxidation. Congratulations, you have been tricked. This is not an oxidation reaction. Why? Let's see this. Let's try finding out the oxidation state. That is the best way. What I've done here, see, this is a compound, total charge is 0. How many chromium atoms do we have? 2, so I've written 2. Chromium, I'm trying to find out the oxidation state, so I took it as X. How many oxygen atoms do we have? 3 oxygen atoms. What is the charge on single oxygen atom? -2. Sum should be equal to 0 because the total charge is 0. It's a compound. So I'm getting X is equals to +3 here. Sorry. Now, Cr3O4. Again, it's a compound, so the total charge is 0. The sum should be equal to 0. How many chromium atoms do we have here? 3 chromium atoms. 3 times X. I'm taking single chromium as X. How many oxygen atoms do we have here? 4. What is the charge on single oxygen atom? -2. So I can say 3x minus 8 is equals to 0. 3x is equals to x. X is equals to 8 by 3. Alright? So we are going from, what is 8 by 3? 2.66. Now, if you check, chromium is going from a charge of +3 to +2.66. Is this increase of oxidation number or decrease of oxidation number? This is decrease of oxidation number, which is reduction. So always oxidation number is the best way to find out whether oxidation or reduction is taking place. What the mistake here was is that students only saw that oxygen is going from 3 to 4, so oxygen is increasing, but also see that chromium's number also increased. Here we had 2 chromium, here we had 3 chromium. So it increased, both of the atoms increased. So the students who picked that chromium got oxidized, their answer was incorrect. Why? The proof is in front of you. In Cr2O3, chromium has oxidation state of +3. In Cr3O4, chromium has oxidation state of +2.66. So this is it. Be aware of these kind of questions. Now, if you have any doubts, feel free to comment on the video. I'll be happy to reply to your doubts. That's it. Thank you.